Day 11, do loop. Welcome back everybody. I'm Prakash Pradhan, your trainer for this entire series. I do understand it's been many days since I have not uploaded the video. I was busy quite in order to upload the video for your grade 10 senior brothers and sisters. So for the grade 9 I was a bit late. So I thought of uploading at least one video for today. So I'm back over here. So now we are going to talk about today one more loop structure, that's a do loop. So without wasting further time, let's go ahead and start how this do loop can be used in your syllabus. Now, the main purpose of using the loop every time that you use in your QBasic programming is simply to execute any kind of statement, a block of statement in your program repeatedly. Okay. Now over here the do loop statement is also used for the same purpose. So if I have to tell you the meaning that is being used over here in QBasic for using a do loop statement, is simply over here given over the screen that the loop statement, that means do loop statement, executes a block of statement of a program repeatedly, while a condition is true or until a condition becomes true. It's the same like that you have been using with the other loop structure, but there is a slight difference over here. If you have a look over here in the syntax for do loop, it has two structures. Number one, do while or do until condition. You are having two statements. That means the two conditions are here. At the same time, we do have another one, syntax, if you see at the bottom, that do loop while or do loop until. These are the conditions. So in between we are going to execute the block of statement. So without wasting your further time, so I suggest you to go through this syntax, and I'm going to show you at least via first theoretical program explanation, and then we'll be moving towards the practical implementation in order to use the do loop statement. So that is going to help you a lot. Now let's see the first sample or the two programs that have been given over here on the screen. Now if you say like if I use simply a for next, you might have noticed that the counter variable value is not needed to be initialized before the loop. Whereas in while when, you might have noticed that the counter variable is to be initialized before we start the loop. Otherwise, one more value is going to be added. So that is the easiest one now. So if I show you over here that in a do while loop, the counter variable value is being initialized over here. If you have a look here, see, the counter variable value is already initialized over here. So then do while I less than is equals to 5 means the value of I is going to be repeatedly executed unless we become or we get the final value of I as a 5. And then we are going to execute the value of I. What is the value of I that you have just initiated over there? That is 1. So it's going to give you first output as a 1. And then since we already know that in do while loop or do loop or while when, the counter variable value need to be incremented by the user itself. It's not like a for next, because in for next, if you do not specify what will be the next step, it's going to add it by default plus 1. That we have discussed so many times. So that's why over here in do while we'll have to add the counter variables value. So that's why I is equals to I plus 1 is done. Now since the first value of I was 1, now we have already executed 1 over here. Now I is equals to I plus 1 means 1 plus 1. Then we already know that loop is going to send you up there in a while. So it's going to make sure that whether I have reached the final value of I as a 5 or not. So in this case, obviously it's not true, it's false. Why? Because just now we executed 1 and we added one more 1 over here. That means 1 plus 1, 2. Now since we are going above over here with the value carrying 2, so it says you have not reached to the final value. So that's why it's going to again send you inside the loop. That means the next execution will be 2. So it's going to execute 2. After that, 2 plus 1, 3. Again it goes back. It says no, it's not 5. So execute 3. Okay. Now it's going to execute 3 as well. And then it does 1 plus, that means I plus 1. That means 3 plus 1, 4. Again it goes back. It says no, it's not a 5. Then again it prints 4 as well over here. So after that, 4 plus 1, 5, and it says, okay, you have reached the final value. I can send you last time inside my loop because my final value was supposed to be 5. Now, since you meet the condition as a true, I can send you inside the loop. So this time your value of I will be 5. So it's going to execute over here. Okay, now, but after that, if you notice over here, this line is going to be executed one more time. That means 5 plus 1 will be 6. Now, if I go back and see, did I meet the final value? It says, yes, you have already exceeded my value. That means I cannot send you inside the loop. That means by the time 1, 2, 3, 4, 5 is being executed, so your work is done. Now, this was a value that is to be printed in ascending order. Okay, what about if you'd like to print some sort of value in reverse order? That means obviously in a mathematical term you might be saying the descending order. So if I need to print the value in descending order, first initial value that is used for the counter variable would be the highest value. Okay, the maximum value that we'd like to start with. So over here we are going to print 5, 4, 3, 2, 1. I guess that you have already understood the output of this program. Now first value of I is 5. I would like to tell you one more time. While using do while loop, over here, if you'd like to print any value in ascending order. So over here, when we declare this variable, counter variable over here with the loop structure, you will have to write the final value over here. That means less than is equals to 5. The highest value where you want to go in a less than sign. Whereas if you'd like to print in descending order, that means you'll have to go in back. That means the reverse value. In that case, the last value will be given over here. See, the last value was given over here as a 5. So we executed 5. Now over here, since we need to print the last value as a 1, that means we're going to print it 5, 4, 3, 2, 1. So that's why the last value is given over here. Now, since the counter variable has already initialized the value I is equals to 5, so do while I is greater than is equals to 1. That means I'm going to continuously execute any block or statement that we have within this until unless I get a final value of I as a 1. Now we are going to print I. What is the value that you have been initialized for this I? That is 5. So it's going to print 5. After that, 5 minus 1, 4. Again, it sends you back. We already know that. 4 is going to print 4. And then we go back minus 1. Then it prints 3. Go back minus 1. Prints 2. Go back minus 1. It prints 1. So after we print 1, again if I go back, that means after doing printing 1, if I do I is equals to I minus 1, that means 1 minus 1. That's a 0. If I go back, it says no, your final value was supposed to be 1. Now since you are coming with the 0, I cannot send you in inside the loop. That means by this time the value is being printed in a reverse order. So this way it works. Now if you notice over here, I would like to show you over here that you do have another one structure over here. Until is also here. Notice over here. Until is also here. So now let's see the example of this until statement over here. Okay. Now, of course, this program also I'm going to explain you. Then this program is quite interesting one. Now over here, I would like to print a value with the help of do until loop. Remember last time we did do while loop, but now we are talking about the do until loop. In a do until loop, what you need to understand, by the time you reach the value of A as a 6, that execution will then stop immediately. That means when I reach the final value of A as a 6, it is not going to send you inside the loop. That means it will stop immediately. That means if I initialize the value for the counter variable as a is equals to 1, how many times it's going to execute? Of course, I do believe that you made a right choice. That means 1, then 2, okay, then 3, then 4, last value execution is 5 because it is already said do until A is equals to 6. That means if I reach the final value of A as a 6, you will have to stop execution. Now, so print A. What is the first value that's been initialized for this counter one? That is a 1. So it's going to execute 1. After that, A is equals to A minus 1. What is the next value now? 1 plus 1, 2. It's going to execute 2. Then plus 1. It's going to execute 3. Plus 1, going to execute 4. Plus 1, execute 5. But after printing the 5, if I come to this line, 5 plus 1, 6. So when it goes back over here, in order to make sure that the condition is met as a true, it says that you have, reached to the value 6. So if the value of A is reached as a 6, I cannot send you inside the loop. So it will send you outside the loop. That means what happened by that time? The value 1, 2, 3, 4, 5 is being printed. So similarly, with the help of this do until loop, we can also write a program to display a table. So over here, I've given one example in order to display the table of 2 up to 10th term. Now, if you see over here, do until B is equals to 11. See here, B is equals to is 11. That means 11 is not going to be executed. So the last value will be 11 minus 1. That's a 10. So I would like to display the table of 2, so that's why I initialized A is equals to 2 and the counter variable value is 1 because we'd like to display the table of 2 up to 10th term, so that's why the first value has been initialized over here as a 1. So do until B is equals to 11 means by the time I reach the final value of B as 11, you need to throw me out of the loop. It means simply that. So print A. What is the value of A? 2. So it's going to execute as it is 2. Then, since the asterisk sign is in between double quotation mark, and since I have been telling you so many times from the beginning, So far I do just remember I have been telling this so many times. Anything you write between these double quotation mark is going to be executed as it is. That means the sign of multiplication asterisk will get displayed as it is over here. No change. Okay, now what is the value of b? See, the counter variable value that I have initialized is a 1, and when I reach to the 11, program will stop. That means 2 into 1 will get executed as it is. But after that, in between double quotation mark, I have also given is equals to sign, and I told you just now also anything you write between double quotation mark is going to be executed as the same. That means is equals to sign is also going to be executed. After that, a into b will take into effect. It comes into action. That means what is the value of a? 2 into, of course, multiplication b. What is the value of b? 1. So 2 into 1 is what? 2, obviously. So 2 into 1 is equals to 2. Now again b is equals to b plus 1. What was supposed to be the last value? 10, not 11. If I reach to the 11, program will throw you out of the loop. Now b is equals to b plus 1. That means 2. Now again we come inside the loop. After going back over here, testing a condition, it will send you inside because you are not 11. Now a is constant. You see, a is constant. So 2 into, what is the value of b now? 2 is equals to 2 into 2, 4. So this way it will display a table of 2 up to 10th term with the help of do until. Now I have another one program, interesting program over here. In order to find the sum of this multi-digit number, actually, if I supply m is equals to 123, the total of this numbers, multi-digit number, will be 1 plus 2 plus 3. That means if I provide m is equals to 123, it's going to give you answer as a 6, because 1 plus 2 plus 3 is equals to 6. Now how are we going to execute this program? So with the help of your do while itself, we are going to use do while loop. Okay, now so in this line it's going to ask you kindly enter multi-digit number. So we are going to give 3. Okay, 3 numbers I'm going to give. That means the value I'm going to assume for m is equals to 123. Don't forget. Now the sum will be 1 plus 2 plus 3 should be 6. Now let's start. So what did I say now? Do while m is not 0. That means whenever I come as a final value of m as a 0, then it will straight away send you outside the loop. So the last condition is 0. That means if I get the value of m as a 0, then my loop structure is over. Now, since the first value we are going to assume as a 123 over here, now what it is going to do? S is equals to m mod 10. What is the use of mod? I guess you made a right guess over here, because the main function of mod is to just to give you the remainder. Now, that means, have a look over here, 123, okay, and mod 10 means what? What is the answer? Now make a guess. It's going to give you simple remainder. What is the remainder? 3. Okay, 123 mod 10 means answer is 3. This one, first execution is 3. Now, t is equals to t plus s. Is there any value in t? No, there's nothing. So t is equals to, because we would like to find the sum of this multi-digit number, t is equals to, t means 0, plus, because there is no value, plus 3. That means when I execute this loop for the first time, what is the value of t? That's a 3. Because m is 123 mod 10. Okay, that means 10 12s are 120. Okay, and then 3 will be the remainder, and that 3 is going to be transferred to the t. So by the time we execute this value for the first time, the value of t will remain as a 3. That's done for the first time. After that, m is equals to m integer division. Don't forget, there's a difference between this division and this division. This is the integer division. Okay, it's not going to deal with the decimal. So right now, what is the value of m that we have just now? That was 123. So 123 integer division 10. Now the value of m is going to be changed. So 123 integer division 10. What is the meaning of this? Let's see now. 123. Okay, and we're using integer division 10. What is the answer? Make a quick guess. What is the answer now? 123 integer division 10. That means that is 12. Now m is 12. So loop goes back and check, is the m bringing a value 0? No, it's not 0. What do you have? 12. So that means you are eligible to go inside the loop. Now what happens now? M is equals to m mod 10. What is the value of m? Don't forget, that's it. Now 12. So 12 plus 12 more 10 means what? 10 ones are 10, remainder is 2. That means that 2 will get transferred into t now. What was the last value of t? 3. Now this time the value of t will be, let me write over here, t is equals to, what was the last value? 3. Okay, what is the current value of s? Remainder is 2. So 2 plus 3 is equals to 5. So I got 5. Okay, now don't forget the value of m. What is the value of m? 12. Okay, now, so 12 integer division 10 again. What is the value now? 12 integer division 10 is 1. Okay, 1. Now, since the value of m is now 1, last time it was 12, now it is the 1. Now, if I go back over here, it is not 0, it is 1. So again, it will send you inside the loop. But now this time the value of m is 1. Can you do the mod to 1 by 10? Of course, the answer is no. So when the mod is not able to give you the remainder, it will give you the same number as an answer. That means the value of this time for s will be now 1. Don't forget, 1. So what was the last value of t? Remember, 5. So 5 plus 1, 6. Now the t is equals to 6. We got our answer, but still the process is not over yet. T is equals to 6 and the m is equals to 1. Now after that we are going to flow to this line. Obviously in the same line. Now can you do the integer division to 1 by 10? No. If the value 1 is not eligible to be doing the integer division by 10, what does it return? I guess you made a right answer. That is 0. So it returns a 0. Now the value of m is 0. Now we go back over here in a loop and it says, are you coming with the 0? It says yes, because now my value of the m is now 0. So in that case, now you are eligible to go outside the loop. Now it will send you outside the loop. So by the time I come outside the loop, what is the value that you have stored in a variable t? Remember, that is 6 over here. So this way, it will help you to find the sum of multi-digit number. If I provide a value 123, it's going to give you 1, 2, 3. That means 1 plus 2 plus 3 is equals to 6. Okay, now after having a brief discussion for the theoretical portion in order to understand how your do until or do while loop works in your QBasic, now let's see practically how those the looping structure can be used in QBasic in practical phase. Okay, so let's start that. Last time we talked about first, that was a do while loop. So let's say I'm going to assign one value. A is initialized as a 1. Okay, so do while a is less than is equals to 5. That means how many times we are going to execute this value? Obviously, I guess you made a right answer. That's a 5 times. So if I print it a and I need to increase the value of this counter variable, as you already know, so is equals to a plus 1. So if I terminate this loop when, okay, and end, if I, not when, it got mixed. Okay, now so loop, do while loop. Now if I run this program, you see the output is this. Now what if you'd like to execute this value? Okay, you'd like to execute this value in reverse order. That means you'd like to initialize a value with the 5 and you'd like to print it with last value as a 1. So in that case, what are you going to do? While a is less than is equals to 1. So first value of a is 1 and then we are going to subtract by 1. Obviously we are going to reduce the value. So if I run this value, there is no answer. Can you make a guess why did that happen? So over here, a is equals to 5. Do while a is less than is equals to 1. Remember, I told you whenever we would like to print the value using a do while loop or do until loop, the value that is going to be the last, if I want to print the value in reverse order, that should be greater than is equals to, not less than is equals to. Okay, so that's why now if I print this value, you'll find the output 5, 4, 3, 2, 1. So it's going to print in a reverse order. That means if you'd like to print the value, okay, in ascending order, it should be less than is equals to. But whereas if you'd like to print the value in descending order, it should be greater than is equals to. So that's why we are going to get the output of this program with the help of this do while loop is this one. Okay, so at the same time, let's do the program that we have done last time in a theoretical portion, like using do until loop. Okay, so I'm going to do the same program. Let's say C is equals to 1 and then do until C is equals to, let's say 4. Then if I print C, then counter variable value has to be added more. That means I need to increase the value of this variable C is equals to C plus 1 and then do until loop. Now if I run this value, make a guess for the output. Is it going to give 1, 2, 3, 4 or 1, 2, 3? And the answer is 1, 2, 3. Why? By the time you reach the final value of C as a 4, it's not going to send you inside the loop. So it's going to terminate the loop and send you straight away outside the loop. So this is the way how your do until loop or do while loop is going to work. So at the same time, so let's have one more example that we have done last time in order to display the table of 2 up to 10th term. Okay, so since we are going to print the table of 2 up to 10 terms, so I need to initialize the value for that 2. Now 10th term, that means the counter variable I need to initialize. Okay, so I'm going to initialize the value for the counter variable b is equals to 1 and then do until b is equals to 11. Why b is equals to 11? As soon as I come to the value of b as 11, it's going to terminate. That means how many times it's going to execute? 10 times. So now I need to execute this value in the full format. That means 2 into 1 is equals to 2 in a complete format. Where is the 2? A. Then into sign as it is. 2 into 1. Where is the 1? B. Okay. Is equals to 2 into 1. That means A into B. Now the counter variable value that you might have seen that the counter variable value over there that we are having in a form of b is initialized as a 1, and by the time we reach to the 11th one, it's going to terminate. That means I need to increase the value of this counter variable myself. So in that case, I'm going to do b is equals to b plus 1, because you know the rule that in a do until, do while, okay, do loop until, you will have to increase the value of this counter variable yourself. Program is not going to do that. Only in a for next it's going to do by default increment for you. So now I need to terminate the loop. Okay, so I need to terminate the loop and then I'm going to end the session. That means end the program itself. So if I run the program, so it's going to display a table of 2 up to 10 term. So what if you'd like to display the table of 5? Simple, I guess. You use your common sense. That means the value for a I'm going to change. So it's going to display the table of 5 up to 10th term. So one more thing, okay, that means one more time, quick revision. If you'd like to print the value using your do while loop or do until loop, if you use do while or do until, so let's take it first for the do while. If you'd like to print the value in ascending order, then it should be less than is equals to. This is a shortcut key I would like to tell you. So if you are printing the value in reverse order, it should be greater than is equal to. So these are the keyword, some of the shortcut tricks that you need to memorize. Now if you remember last time, we did a one wonderful program in a theoretical portion that was to find the sum of 3 digits number that's been supplied by the user itself. So let's do that program first. Okay, now for that I'm going to ask you to supply any 3-digit number. Okay, enter any 3-digit number. Now what we're going to do, we are going to write a program over here in order to find the sum of these 3 digits. If I supply a value 222, it's going to give the answer 2 plus 2 plus 2 as a 6, and the theoretical explanation I've already done in previous. Now so let's see. Okay, it's asking you to supply value b. So okay, now while, okay, let's say do while b is not 0. That means as soon as I get the final value of b as a 0, program will get terminated. Now the first thing I'm going to assume, let's say the value for b is 222. As we did last time in a theoretical explanation, the value for the a was 1, 2, 3. So if you like to go for the same, no difference, program is same. Okay, so let's assume for you 1, 2, 3. In that case, no problem. So first I need to extract the 1. That means if I supply a value for b as a 123, so I need to extract first 1. So in that case, how do you think it's going to help you? So let's say c is equals to b mod, okay, b mod, what do you like to write? 10. Okay, no matter you take from the right or you take from the left or you take from the center, it doesn't make any difference, because ultimately we are going to find the sum of the numbers. Okay, now let's say t is equals to t plus c. So what do you have in a b? If, see, I'm going to repeat, what are you going to store in t if the c is equals to b mod 10 and if the value of b is 123? So what is the function of mode? It's going to give you the remainder. That means if the 123 is divided by 10, so the exactly remainder is 3. That means when I divide 123 by 10, I'm going to get 3 as a remainder. So I'm going to store that 3 in a t. So don't forget, now t means 3. Okay. Now after that, I need to do the integer division as well. So for that I'm going to do, so let's say d is equals to, okay, b integer division 10. So what is the value of your b at this moment? Remember 1, 2, 3. So when the b is done, the integer division 123 integer division 10 means what? 12. Okay, so now d is equals to 12 in that case. Okay, but when I go next time up, so I'm going to divide the same value b only. So is it okay? No. You should understand, you should give this b only. Why? We are trying to change the value of b, not the d. Because if I go back, it's going to divide again the value for b only, not d. So that's why don't get confused here. You will have to use the same value that you have supplied for the counter variable. Otherwise, the loop is not going to be terminated. Remember, when we get the value of b as a 0, then only your program is going to be terminated. So that's why I'm going to do b is equals to b integer division 10. That means, what is the value of b? 123. Integer division 10 means what? Obviously, it's a 12. And don't forget, the value of t that we have stored is a 3. Okay. Now, so now I need to terminate the loop. Okay, now I'm going to write, let's say, sum of 3 digits number is equals to, what is the sum? T. So let's see the next value. Remember, last time value of t we have assumed as a 3 because the value for b we have given 123. Now b is equals to b integer division 10. That means what is the value of b now? 12. So when I go back, b is not 0, it has to be 0 in order to exit from the loop because the value of b is right now 12. So now 12 mod 10. That means what? It's a 1. 12 mod 10, because when you divide 12 by 10, what do you get? 1? Think once. No, it's a 2. Why? 12 mod 10 means the 12 is going to get divided by 10 and it's going to give you the remainder. We are not using the integer division over here. So that's why don't get confused. Now b is 12, 12 divide by 10 and it's going to give you the remainder. So what was the last value you stored in a t? Remember, that was 3. 3. That means now t is 3. What is the value of c just now? 12 mod 10 means 2. That means 2 plus 3, 6. Now t is holding the, sorry, 2 plus 3, 5, not 6. 2 plus 3, 5. Now after that we come over here. Now you tell me what is the value of b. Because the last time the value we had over here was the 12. Isn't it? 123 integer division 10 means 12. Now 12 integer division 10 means what? 1. Now it's a 1. Okay. Now if I go back, is this b is equals to 0? No, it's a 1 because it can divide only 1. Okay. Now when I do 1 mod 10, what will be the answer? 1. Don't forget. If the mod is not able to divide the given number in order to find the remainder, it's going to return the same number as an answer. So by the time, what did you store in a variable t? 3 plus 2, 5. Now over here, b means 1. 1 mod 10. That means answer is equals to 1. That means the value of c is now 1. So 5 plus 1, 6. 6. Now, what is the value of b? Just now we saw it's a 1. So when integer division is not able to divide a number given by you, in that case, it is going to return 0. You see the difference between this mode and this integer division. If mode is not able to divide a number, it will return the same number as answer. Whereas if the b, that means the integer division is not able to divide a user supplied number because the value for b is 1. We already know 1. So 1 cannot be divided by 10. In that case, this integer division will return as a result 0. So what do we have now in b? 0. So what is the condition you said over here? When we get the value of b? 0. If it is not 0, then continue. If it is 0, you will have to exit. So that means, do you think it's going to allow you to go to next line? Obviously, it's not going to allow you to go to the next line. That means it will throw you straight away outside the loop. So by the time, what did you store in a variable t? 3 plus 2 plus 1. That was 6. 1 plus 2 plus 3. Okay, so if I run the program, it's going to ask me to provide a 3-digit number. Let's say 1, 2, 3. What is the answer? Now guess 1 plus 2 plus 3, because the sum of the 3-digit number over here is obviously 6. Congratulations, successfully done. So how about that you'd like to test some other number? No problem. The program is same. It's going to give you 2 plus 2 plus 2, 6. So how about one more time? Okay, let's run one more time. So this time I'm going to give 999. What is the answer? 27. So no matter what value you are going to provide over here, so it's going to give you the same output. So we saw the program, how do while loop works, okay, and how do until loop works, and how we can solve a problem with the help of do while in order to even find the sum of 3-digit number in a QBasic program. Of course, I do understand there are many questions that can be solved using this loop structure, and of course in the days to come we will be able, or we are going to write more and more program. So for this session, I hope it's more than enough for you to understand how do while loop and how do until loop, and how do until b is not equals to 0 is also functioning over here. Okay, so I do believe it was, kind of easy explanation for you all to understand how this do loop works in a QBasic programming. So I tried my best to explain in the easiest way, giving a simple programmer. In the days to come, we are going to write some more program, advanced type of program. So if you find it fruitful, please do like and subscribe. Thank you.